Hi everyone, Physics with Sean here with another physics practice problem. So today we're gonna start our topic of vector math. This is super important for really every level of physics, but especially for your intro physics. This is some foundational knowledge. This will be really important for your intro physics courses. If you've already seen this kind of math before, you can treat this video like a little practice session. Maybe try to do this problem um, right now and then come back to the video and see how I went about solving it. If you haven't seen this before, this will be a nice intro. See what you're in for um, your intro physics course. So yeah, let's hop right into it. So this problem says that we have two ropes in a vertical plane that exert equal magnitude forces on a hanging weight, and they pull with an angle of 72 degrees between them. What pull does each rope exert if the resultant force on the weight is 372 newtons in the upward direction? So before we kind of get in straight to solving this thing, let's kind of break this problem apart a little bit. And this is really just illustrating what goes on in my mind as I try to solve this. If I was, this was on an exam or something, what would I do? How would I think about this? The first thing that really jumps out to me is that we have this weight, and acting on this weight is a resultant force. In addition to these, forget the two ropes and everything else going on here. Something that jumps out to me is the resultant force is 372 newtons upward. So I kind of have this image in my mind of a weight that is being pulled straight upwards by some force. And more specifically, this resultant force is really important. Resultant force means that it's just the sum of all of the forces being applied to this object. So the sum of all the forces is 372 newtons or whatever number directly upwards. So with that knowledge, let's do what I consider to be probably the most important thing for solving any physics problem at any level, which is drawing a picture. Of course, at some of the higher levels of physics, it gets harder and harder to draw a picture. Maybe it's not always feasible, but for this type of problem, we can handle it. So for this, draw a little XY coordinate here. Actually, I'll label it. I'll say this is X, this is Y. And in this picture, I'll draw the weight. So they talk about there's some weight being acted on by all these forces. So I'll just draw here. It's just a red blob right there. That's our weight. And acting on this thing, let's just talk about what we were just looking at, which was the resultant force going upwards. I'm going to draw that. I'm going to say, okay, there's some force going the upward direction here. I'm going to label it. I'm going to say that this is, I'm just going to name it force C. That. Force C going upwards, acting on the weight. I'll write over here too, I'll say that the magnitude of force C, just like how many newtons, like what's the number value of this force, is just what it says in the problem, 372 newtons. I'll just write it there so I can remember that that's important. And then we'll go back to look at this problem, the first half of this problem, and see that it says that on this weight, in addition to this resultant force, there's these two ropes that are exerting forces on the weight of equal magnitude. That's important. So actually, before we even do anything, let's just write that down. Let's say that the magnitude of, I'm just going to call these two forces force A and force B. So the magnitude of force A is going to be equal to the magnitude of force B, because that's what it says right there in the problem, equal magnitude. And both of these things are equal to some number, but I don't know what it is. And in fact, that's what we're trying to solve here, right? What pull does each rope exert? We want to find that number. So let's draw that in our picture, though. Let's say that force A is going off this way, like that. And force B, well, think about this for a second. It says that there's an angle of 72 degrees between force A and force B. So actually, oops, we'll say that this one is force B. moment. This is force B going off that way. So force A has to go, we have to have 72 degrees between force B and force A. But more importantly, these two angles, or sorry, these two forces have to be such that the result of them both acting on this weight pulls the weight straight upwards. So that means, in my mind, is that in order for the resultant force to be going straight upwards, the components of force A and force B in the x direction, the side-to-side direction, have to add up to equal 0. Right? Because if there's any side-to-side forces, if that number wasn't 0, then the resultant force, the weight, would be pulled off to one side or the other side. But it's not. It's going straight up, which means that these components have to be such that the x directions of A and B add up to 0 newtons. So what that means for our picture is that A and B are pointed in the exact same amount, side to side, just opposite. Right? A is off to one side, B is off the other, the exact same amount. So that's good. That kind of simplifies things. Then we can kind of get rid of, we don't have to think about the x components of this. But just to round this out, let's put this here, say 72 degrees is the angle between A and B, right? Because that's what the problem says. And just to make things a little bit easier for our future selves, let's relate the angle that each of these forces makes with the y direction, the y-axis. So since they're pointing in equal, they're equal in magnitude, they're pointing in equal directions and side to side and up and down, we can say that they have bisected this angle. So that means that force B makes an angle of 36 degrees, which is half of 72 between it and the y-axis. And force A, force A also makes an angle of 36 degrees from the y-axis. Okay, so now we've got our full layout of the lay of the land here for all of our forces acting on our weight. And so we can really just start solving this thing. We already sort of talked about what the x components are doing. They're doing nothing. That's good, so we kind of took care of that. But now we can say, okay, well, what's going on with the y components? The y component of A plus the y component of B. Well, that's got to be equal to the y components of C. Right? Because C is the resultant force. It's at the addition of all the other forces, A and B. And this is, you might notice, right, this looks very similar to what we were just doing with the x components. In fact, it is. One thing that we kind of skipped here was that the x component of A, x component of B added together is equal to really the x component of C, which we just said kind of automatically it was 0 newtons. We're saying the same thing here. The y components of A and B added together is the y components of C. Same thing, but just talking about different components. So now, to break this down even further, let's actually put some numbers here. I know that the y component of C has to be this 372 newtons, right? Because all of force C is going in the upward direction, in the y direction, y component. So all of that number, all of 372, it's all there for the y component of C. Now, let's take this one at a time for A and B. We'll start with force A, the y component. Before we get too much in detail, I just want to remind you for when we're looking at trigonometry, when we're looking at angle, or I guess a right triangle, this angle here, theta. If I were to take cosine of theta, what I would get is the following. The cosine of that angle is equal to the value of the adjacent side, the length of the magnitude of the adjacent side, divided by the hypotenuse. we can apply that same thing, same logic to our picture here. So let's look at force A and draw it out here. So this is A going off like that. I'm just redrawing the picture slightly differently. Oops. We've got force C. This, or not force C rather, but just the y-axis going upwards here. So the side to side here. So we've got this right triangle here, thinking about force A. See, I just kind of redrew it there. And we said that angle there between force A and the y-axis was 36 degrees, right? And so some simple trig, you might have to kind of rotate this, this triangle a little bit to match what we were just talking about right here. But you can see that that triangle looks the same, such that the cosine of, in this case, 36 degrees, cosine of that angle, is going to be equal to this adjacent side, which, if we look at this, the way we drew this triangle here, the adjacent side is equal to the y component of A, right? That's just how high up, how much in the up direction is the vector A going. Y component of A divided by, we're just following this equation here for this equation for cosine, divided by the hypotenuse of this triangle, which is, hypotenuse is just the magnitude of the force A, right? Just going off this picture. And so moving this around a bit, reorganizing this, we can say that the y component of A is equal to the magnitude of A times cosine of 36, right? Just rearrange that equation there. So that's great. Let's put that up into our equation here. Getting a little messy here, but hopefully you can follow along. Magnitude of A times cosine of 36. We're just replacing this here, the y component of A, plus, and then we can do the same thing for vector B, and just take my word for it here, but we end up with a similar thing. Magnitude of B times cosine of 36 degrees for the y component of B. You can check that math for yourself at trigonometry. But this is our equation here that we need to solve this problem. We're almost there, but if you look at this, say, well, I've got two unknowns. I've got the magnitude of A and the magnitude of B, and just one number to work with on the right-hand side. This doesn't really seem like it's very solvable at the moment, but we have to remember something from the beginning of this problem where we said that these two ropes, I call them A and B, the two ropes exert an equal magnitude on the weight. So remember what we said up here, at the very beginning, we said that the magnitude of the force A and the magnitude of force B, these two vectors, are equal to each other, and they're both equal to some number. And so if they're equal to each other, that means I can rewrite this equation and say that the magnitude of A times cosine of 36 degrees plus, and instead of saying the magnitude of B, I can say, well, that's just the same thing as magnitude of A, equals to 372. Oops, ran out of space there, but you get the idea. So I can put this all together and say that becomes 2 times the magnitude of A times cosine of 36 degrees equals 372 newtons. And it's just a little math there. Our calculator can help us out. And we get that the magnitude of A is equal to 230. Oops, 230 newtons. Make that more clear. 230 newtons, which we can also say is the magnitude of B is equal to 230 newtons as well, because they have to be equal. We decided that at the beginning. And that's our answer. There we go. So the process of solving this problem was breaking it down into what parts of this, all the words are thrown at us, what parts were important. How do we draw this into a picture that makes physical sense of what's happening to this weight? And then breaking it apart and actually applying some trigonometry to this. And so hopefully this was helpful. It's a good practice problem, or if you've seen this before, it's just good, good reminder for some simple vector math. If you weren't too sure about what was going on with the cosine stuff, all the components, I'll have some more videos up on how to work with that. I think it'll come more naturally the more practice you get. Yeah, hopefully this was helpful. Stay tuned for some more practice problem content.